Very good evening, sir. Very good evening, Lakshmi. How are you? Good evening, Aditya. Where are you, Aditya? Actually, after so many days, you joined the class. Can you just tell me, like, everything is okay at your end? Because at my end, it keep loading, loading, loading. Oh, okay, not an issue. Of course, you're a JS parent, so you have to go with the math, right? Chemistry is not, important. I guess we have to start. Oh, I was just kidding. Not an issue, okay? Okay, then let's just start. Okay, let's not waste their time. So yeah, of course, it is going to be the fifth session on alcohol and phenol and ether part there. So let's just start. In let me just quickly give you a brief, like what we discussed in the previous class. So, in the previous class, the last topic we discussed there that if let's suppose you are having some kind of R which is there, or you can say alcohol, and in this, if you to add acid, like let's suppose HCl have to be there, right? So, what is the product we are getting? That RCl plus water have to be there. Right, there we discuss about if this reaction is going to follow the SN1 reaction, so then how about the mechanism? Tertiary is reacted first, then secondary, and then followed by the primary one. Right, so this part we already covered in the previous class, and there that's it. What we're discussing there, let me just again explain this point that we discuss all these thing under this that if you have to break the bond, wait, if you have to break the bond between R, O, and H, okay, so this time we are breaking this bond here, okay. So in this bond breaking, we just discussed the first type that is a reaction with, okay, reaction with acid, or let's say hydrogen, hydrogen halide. It can be HBr, it can be HCl, it can be HI there, okay. So the next is going to be the reaction with, okay, that how about the reaction with phosphorus, phosphorus chloride, okay, phosphorus chloride. So let's discuss about this point now, okay. This is the second reaction, or you can say the first topic of the today's class, okay. So let's just start with this, like what does actually how the reaction look like. So first of all, that we can say it's a general reaction, okay. How about the general reaction in this case, that if let's suppose you are having some R which is there, okay, I'm using phosphorus chloride as we discussed. So in the phosphorus chloride you can use PCl3, okay. So PCl3 if you are using here, so what we are getting simply that there is a formation of RCl, okay. So simple, as we are discussing about the chemical property of alcohol, so this is how we are getting there, okay. So very good evening, Niharika. So this is a simple reaction with PCl3 there, okay? Now, let's discuss about the mechanism part. How about the mechanism there? Okay, so let me just write the mechanism. Although it's not really important for the board exam, but just try to understand the mechanism. Okay, so let's try to understand the mechanism. How about the mechanism of a reaction there? So if let's talk about the mechanism. So first of all, we are having a P, phosphorus is there. Okay, right? And then that is this is some ROH is there. Now my question to you, between this ROH and this PCl3, which one is being like a nucleophile? Like that ROH is going to attack on PCl3 or PCl3 is going to attack on ROH? If not very clear at your end. So what I want to ask simply here that phosphorus is a lone pair, right? Because it's belong to the nitrogen family. So the condition number one, maybe it attack here. Okay, the condition number two, that obviously the oxygen also has a lone pair. So right, what is the second condition here? The second condition we like maybe the RH attack on the phosphorus. So according to you, which one is the feasible attack? This is my question. RH attack. So Aditya, but phosphorus as a lone pair, then where is the phosphorus is going to take the extra lone pair? Okay, you're also right. But like where we're going to use that extra lone pair? Hello, Venom. Very good evening. Yes, please answer this question. That why not phosphorus? Because phosphorus also has a lone pair. You know, in organic chemistry, oxygen is the first that is the second period element, that is the first member of the group. So oxygen will like, okay, you are going to give me, but I'm not having any kind of vacancy. But phosphorus be like, not an issue, I'm a third group, sorry, third period element, and you can give me the lone pair simply, right? So means that's why what is the feasible attack, that this yellow one, okay, so not the pink one. Okay, sorted. So it means this is going to attack be like this, okay. So now, okay, so I'm erasing this, wait. This lone pair attack on the phosphorus there simply, okay. So how about the bond formation is there? That R, O, and H. Since oxygen form extra bond, that's why oxygen receive a positive charge, or the oxygen got a positive charge. Then this is phosphorus. There is a one chlorine and there is a one chlorine. Be noted. In this case, what is happening there? As soon as the lone pair attack here, one chlorine leave. Okay, I guess everyone you know now that is chlorine is a very good living group. Okay, so it's behaving like a living group because phosphorus form three bond here. So like oxygen take the place of a chlorine, chlorine leave the molecule there. Okay, now the next question. For example, now in the reaction like Cl negative release, okay, Cl negative is there. So there's a Cl negative has a two choice. Maybe the Cl negative again take this. Okay, condition number one. Because this is a organic chemistry, we have to apply each and every possible condition. So according to this condition, if let's suppose this chlorine attack on hydrogen, so what we are getting simply that is this is RO bond and this is a PCl3. Okay, but no, we don't want this. As we discussed the general reaction here, if you have to observe, this is my alcohol and this is my RCl there, simple. So like how it is possible for this chlorine to attack here? So be noted like what is the problem? We are having chlorine and H. Okay, this is H positive and it can be released. But be noted, chlorine is not going to attack here. So that's why this is not a feasible attack. So now chlorine attack here. Of course, the chlorine attack from the top position. That is, this is a Cl. Cl simply attack here. Okay. If this attack here, obviously this group is going to leave. Okay. So I'm erasing this that chlorine is not going to attack on a hydrogen. Only the chlorine is going to attack on the R group there. So how about the second thing that okay, we are getting RCl plus, then this become PCl, PCl, and then R OH is there. Oxygen still has a lone pair, okay, and the sides only the molecule. So this thing is basically converted into the phosphorus, chlorine, and chlorine. Okay, this phosphorus still has a two living group, so the process will continue. Okay, although like this is the enough, if this is enough for the reaction, but okay, again it is going to react. Okay, this one also has a choice. Let me just explain on the next slide. That what will be the next point? That if let's suppose, oh sorry, okay, R which is there, and this is a P and O Cl, and then it's a copy and paste. Like again, this O attack here, this chlorine leave, and then again you're getting R OH. Okay, and then phosphorus, in this case double bond, and then chlorine, and then again the chlorine attack from the top, this bond leave, and we are getting again RCl plus POCl and OH is there. Okay, so this is how it keep continue further, and then again there's a one more Cl left. So this is how, with the help of the PCl3, we are able to simply convert 3 alcohol into the 3 alkyl halide. Okay, so this is all for the reaction there. uh, okay, let me just explain this here, that R O H, and this is a P or and a Cl there. So this is how the bond break. Okay, this OH attack here. Okay, and this oxygen is a lone pair, and this is how. So we're getting P double bond O, and this is O double bond O, and this chlorine attack here. So one, two, three, and one hydrogen is there. Okay, so again one more chlorine left, and then same reaction is going to proceed. So what I want to highlight, that mechanism is not really important. Just try to understand the thing, that which kind of question frame from this, if it is an integer type question. Okay, so if it is an integer type question, so which kind of question asked from this topic, that how many mole of oxygen, sorry, how many mole of the alcohol is reacted with the PCl3? Yes, please. My question is what? That how many mole of alcohol is going to react with 1 mole of PCl3? Okay, the integer type of question asked from these kind of questions. Yes, please. Options are 1, 2, 3. How many mole? So PCl3 has a 3 chlorine, so obviously it is going to combine with 3 part here. Okay, so at the end, what we are getting, yes, 3, you're right, Lakshmi. Yes, 3, 3, everyone is right, okay. So that's it, this is all for the reaction with PCl3 there. Now let's see the third reaction, and you know about this. Let me just again move toward that slide where we're discussing all this. Yes, the second topic. I'm erasing this now. So this third reaction is what? That is a dehydration. Dehydration of alcohol. Okay, so you can typically say it's nothing, it's an elimination reaction. Remember the last question of the previous class we discussed about this, that it's nothing, it's a simple elimination reaction there. Okay, so now let's try to understand what is the dehydration of alcohol. So let's just talk about that as a dehydration of alcohol. Okay, so let's see a general reaction. First of all, let's suppose you will be having some CH and then CH2 and then OH is there. Okay, so in this case, we have to add some kind of acid, and then what we are getting simply, that is a CH3 and then double bond CH2 there. Okay, but don't say ma'am, see in the previous class we just discussed that okay, if this H positive is there, oxygen has a lone pair, it's attack there, so isn't it this is behaving like this is a positive charge, right? And water molecular release, then what is so special about the dehydration of alcohol? So you will tell me that after this step you are having two choice. The choice number one, that maybe some nucleophile is there. So if nucleophile is there, nucleophile is simply attack here, and we are getting it's a CH3 and a CH2 and nucleophile. The complete reaction mechanism part pretty much explain this thing to you, that whether we have to consider the elimination reaction or the substitution reaction. Or the choice number two, maybe that is in the same. Let's suppose I'm having CH3. I'm erasing this. Okay, maybe I'm having the CH3. Okay, and this is some CH2 and positively charged. Maybe there's some base came into the picture and attack here, and maybe okay, that double bond have to be there. Right. So let's first of all discuss about the main point about the elimination reaction. That in which point you have to proceed with the elimination reaction. So I guess you already know that is the condition number one. Strong base required. Okay, strong base required there. Second one, that is a large size of okay, base, or that is a high temperature required. So you can say minimum three condition have to be there for a normal elimination reaction. Although we know E1 and E2 different factor we already covered in the reaction mechanism, but main point, these are the main point. Okay, now let's see how to proceed with this. You will tell me the answer for this question. This is a question for you. Okay, question is this. Uh, yes, this is a CH3 and it is a CH2 and it's a OH, and I am using BF3. Okay, and CH2, CH3, O negative Na. So you have to identify the product. This is my question to you, okay? So you have to identify the product. So the answer, like options are, first of all, wait, it's a CH2 and then CH3, okay? So simply, that is what are the options. This is a CH3, carbon, double bond, CH2. Option number B, it is a CH2 or OCH2 CH3 group connected. Okay, I'm sorry. It's CH3 and CH2. Okay. Okay, that is two possibilities. So between A and B, which one you are going to follow and why? Option A is correct or option B is correct? What is the correct answer for this question? But this time I'm not using any kind of acid, right? Okay, Lakshmi, can anyone tell me the use of this BF3? Because here I'm not using H positive because I just explained to the reaction on the basis of if let's suppose I'm having H positive ion, but there's no H positive ion present. Then what is the use of this BF3? That's why organic chemistry is really important, right? Like everything has a point. It's not like I just write the BF3 because I want, right? No. Only Lakshmi, how about other? What do you think about this? For vacant orbit. Yes, very good. Okay, what is it? It's a Lewis acid, right? We know this BF3 is a Lewis acid or not. Why? Because this one has a vacant p orbit. Here we are having a 6 electron. Sextet is there. Octet is not there. Definitely it is going to accept. Okay, and OH will be like, I'm not a good living group. So BF be like, not an issue. Just combine with me. I hope you already know that OH is not a living group, good living group. But once this OH combined with, let's suppose the BF3 is connected here. So look at this. That is the bromine is now connected with the 3 fluorine and this got the negative charge. And now this one, this BF3 forcing the ROH just to leave. Why? Because again the oxygen have the positive charge. You know, the oxygen has a positive charge is really unstable thing. So what is the normal point that if you are having R OH or BF3 is written there, so be noted it's nothing that we are converting the OH into a very good living group. So at the end we are getting only R positive, right? So this is how we are going to follow. So let's just move again here. So in this reaction, basically that once this BF3 connected here, so let me just write the same step here, okay? So just try to understand that if this is this BF3 simply connected here, this oxygen has a positive charge and this molecule leave. Okay. So now what we are getting simply there, that is it is a CH3 and a CH2 and a CH2 there and positively charged. Okay. So now what is it? What is it? Options are it is a very good base or a nucleophile. Because we I guess we discussed this thing so many times, right? Okay, Niharika. You know what is this? The thing which is present in a box, that alcoholic KOH, if you remember, right? So if you are having alcoholic KOH, then what we are getting? The double bond or like kind of nucleophilic addition or substitution, I'm sorry. Yes, please. What is it? It's a very good base. It's a very good base. We discussed this point so many times, right? And then still you are saying that option B is the correct. So it means something is wrong, right? So please be noted, revise the thing. So it's a very good base. Okay, not an issue. It's a very good base then simply. So this group is going to attack here. Okay. So this O negative, as we know, this sodium has a positive charge, this one has a negative charge. So this is simply attack here on this hydrogen, this bond leave, and we are getting simply that in this case, this is a CH3 and a CH and a double bond CH2 there. Okay, so this is the simple answer for this question, option number A. Okay, option number A is the correct here. Now the next question, between E1 and E2, which mechanism we are going to follow here? Okay, option A is the correct here. But which mechanism we are going to follow here? Is it E1 or E2? Because elimination also has some part, right? So should we have to go with E1 mechanism or E2 mechanism? Some may be like, ma'am, you explained the carbocation formation, so maybe you can go with the E1, right? But the thing is enough already there, which pretty much explains should we have to go with E1 mechanism or E2 mechanism. So remember, for the E2 mechanism, for the SN2 mechanism, we are requiring a strong base or a strong nucleophile. So yes, it's a strong base. It's not only base, but actually it's a very, really, really strong base. So which mechanism we are going to follow here? That is a E2 mechanism. So these kind of question you have to ask to yourself in the organic chemistry, like what the question want to ask. When you're analyzing the PYQ, it's not like we are solving the question, we are eliminating the option. No, just try to understand each and every point, just check your knowledge. Okay, that's it, this is all for the question. I hope now the dehydration part is clear for everyone. Okay, so now let's see the second point. Okay, so we already covered the three reaction. The first one, that reaction with the acid chloride. Okay, the second one is what that we discuss about, reaction with PCl3, and the third one is this dehydration one. Now let's see the fourth one. Again, let's move the slide. Okay, so in this part, now the second, okay, that not second, fourth one. How about the fourth reaction there? That is, the fourth reaction is what? Oxidation reaction. Now the real part start. Okay, oxidation reaction there simply. So let's just first try to understand what is the meaning of oxidation of alcohol there. Okay, so let's start with the oxidation of alcohol. So first question, what is oxidation? What is oxidation? Like in term normally, that is, you can say the gain of electron or loss of electron. Which one is correct? I thought F replace OH in place in case of PCl3. F means you mean to say fluorine? Wait, I will check what you are saying. Wait a minute, okay? Which F you are referring here? Okay, you mean to say the mechanism is not like that, okay? In the question part, wait. Like this? No. Fluorine is just already combined with the BF3. Okay, the only use of the BF3 is what? BF3 being like a Lewis acid. Like in the previous one, we are having H positive. Okay, H positive has a vacancy. Same like BF3 is also has a vacancy. Okay, so it's just behaving like just the only main motto of the BF3 to release this O like OH ion is there. Maybe you already know there's a some very good group which is going to connect with any kind of living group, that OTS group. Okay, tosyl group. Maybe you don't know, so it's a TS group, tosylate, okay? Tosylate. And one is MS, that is mesylate. Okay, like this. So maybe you're observing the reaction that if let's suppose you're having OTS group, so it's also a very good living group, or you can say OMS, it's also a very living group. So the only purpose of these things just to like increase the strength of a living group, okay? Just to increase the tendency of a living group. Okay, don't worry, we're going to discuss each and every point in very detail in the upcoming classes, but try to understand my point. Okay, Lakshmi? Okay then, so let's continue again what we're discussing. Yes, please. So yeah, you are right. What is the oxidation? That is a loss of electron. If sometime you are having a problem, that is it's a universal example. I used to remember the zinc one, right? Zinc is going to convert in the Z into positive, and plus two electron have to be there. So what is it? It's general oxidation. So means from there to there, 0 to 2, it's become oxidation, loss of electron, right? So simple. That is a loss of electron. Okay, the condition number one. Any more point that we can use here? I'm not going to ask you about according to the redox point of view, just simple. Like in term of hydrogen, is it gain of hydrogen or is it loss of hydrogen? What is oxidation? Okay, so gain of oxygen. Okay, it's a loss of hydrogen, right? So yes, simply let me just quickly write. So what is it? It's a gain of oxygen. So you can say it's a gain of oxygen. Or the third one, it's a loss of hydrogen. Okay, simple. So it means that what we are going to do there, if you are having some ROH, ROH first of all converted into that some RCOH group. Okay, what is it? Aldehyde. Again, if it undergo oxidation, what is the last point we're getting? That is acid. So, like if you remember the reduction part in the previous chapter, so same here that if you want to convert this from there, we are using a very strong oxidizing agent, we are requiring a very strong oxidizing agent. Okay, if but what if I want to stop the reaction till here, so what is it? It's a partial oxidation, or you can say that is a not very good strong oxidizing we are using. Normally you can use any weak oxidizing agent. Okay, but the point is what actually how we can define it as oxidation there. Okay, so let's count that only the oxygen part. Here one oxygen, okay, and here one oxygen. There's a no change in oxygen number. But if you to observe from here, like let's just write the carbon as well. Okay, like this. So see this carbon here. That before the reaction how many hydrogen is there? If you to observe, two hydrogen, okay, and one three hydrogen total. So you can say before the reaction how many hydrogen total we are having? That is a three hydrogen. And after the reaction how many hydrogen is there? There's only one hydrogen. So see this, what is this? Loss of the loss of the hydrogen, so it's a oxidation. Okay, from here to here. But on the other hand, if let's suppose we are moving for this point, that look at this, then what is this? That if you're observing the same thing, that okay, hydrogen is same, one and one number is there. So what is happening in this case? That is one hydrogen before the reaction, one hydrogen after the reaction. Then what is the new point here? One oxygen, but now it's become two oxygen there. So one oxygen before and now it's become two oxygen, right? So what is it? It sorry. Okay, so what is it? It's a simply that is a gain of oxygen, that one oxygen become two there, and it is oxidation. Okay, so like make this point very clear. What we are going to do, we are going to convert an alcohol into the aldehyde or either the acid there. Okay, so now let's try to understand what is the possibility there. So obviously we are having a three kind type of alcohol there. The first one is what? Primary alcohol. If you are having a primary alcohol, so let me just write any example. Okay, let's see any general example. This is CH3, okay, and it's a CH2, and this is a OH. So if it is going to oxidize, there's a two choice. The choice number one, the terminal one, maybe we are getting a aldehyde, or that if you're using a mild, very strong oxidizing agent, this is for the mild one. So we can say that it's a CH3 and a CO and OH is there. So the two choices there. So we can simply say if you are having a primary alcohol, either we are getting aldehyde as a product or acid as a product, carboxylic acid as a product. Okay, cool then. Now, what if I'm having a secondary alcohol? So then, secondary alcohol is going to convert into what? And you will tell me the answer. Options are aldehyde or acid or ketone. Same, if it is undergo oxidation there. So first of all, there is any aldehyde formation? No, right? Normal. So in this case, we are getting only that is a one possibility that we are getting a ketone there. So it's a R. Oh, sorry. This is normally a ketone. This is a CH3 carbon double bond CH3. So it's a ketone only. So in this case, this is not extra point that you will be having some acid because the OH group is the in the very center of the molecule. How about the tertiary alcohol there? Okay, how about the tertiary alcohol? So in this tertiary alcohol, if let's suppose you are having this is a tertiary alcohol is there, and if it is going to oxidize, so make this point very clear. There is a no reaction. There is a no reaction for this case, and you will tell me the reason why not. That why not there is a no oxidation take place for the tertiary one. Think about it. Okay, just answer this question. In primary alcohol, how many alpha hydrogen? In primary alcohol, how many alpha hydrogen is present? Same for the secondary and same for the tertiary. And this is the answer for this question. Yes, please. Primary, secondary, or tertiary? Two, right? And like if you to go with the this point, so there's a two alpha hydrogen. Okay. So in this case, there is a one alpha hydrogen, and in this case, there is a no hydrogen. So what is the key point? That is in this case, two alpha hydrogen. In this case, there is a one alpha hydrogen, and in this case, there is a zero alpha hydrogen. If hydrogen is not present, then who's going to lose? Okay, like till now what we are doing reduction, sorry, oxidation is what, that is a loss of hydrogen or gain of oxygen. If hydrogen is not present there, then which one is really going to lose here? So that's why be noted, tertiary alcohol never ever undergo oxidation. Yes, it's fixed, it's not going to oxidize anything. Okay, that's it. This is all for the topic. Now let's start with the different kind of reagent which we are going to use for the oxidation point. Okay, so let me just check, let me just give you some normal that oxidizing agent. And yes, reagent part is really very important. I don't know what you're going to do, but at least remember every reagent with the function, like the naming relation. It's really important. So let's start some oxidizing agent. So just answer some oxidizing agent if you know. The one is what? KMNO4, right? Our favorite one, KMNO4, in acidic condition, you can say, or basic condition as well. Any more? Any more? Come on, if let's suppose I'm asking about the strong oxidizing agent. So everyone you have to answer the KMNO4 and K2CR27 at least, right? I'm not asking like you to remember so many things, but at least know the basic, right? So you can say KMNO4 or you can use K2CR207. Okay, or still acidic condition have to be there. So these two are the strongest oxidizing agent of the chemistry, you already know, right? Next is going to be the Jones reagent. We are going to discuss about this part as well. So it's a Jones reagent. Okay, and then anhydrous Cr, it's a anhydrous CrO3. Okay, what is it actually? It's CrO3 plus H2SO4 is there. Okay, so actually this is a John reagent plus H2SO4. Or the last one, not the last one, PCC, okay? PCC. Again, it's important. Let me just highlight this as well. So it's important because this is the reason behind the exception most of the time. So it's a pyridine. The pyridine, pyridinium chlorochromate. Okay, we will discuss every point. Just wait. Okay, and the last reagent is going to be the copper. Okay, I'm writing this here. Copper oxide in the form of heat. Generally, for this reaction, we are requiring 573 Kelvin as a temperature. It can be changed, but generally. So let's start with this point. So for this KMnO4 and K2CR27, we already know everything that what we discuss in the 11th class. They are very strong oxidizing agent. If I'm talking about the like acidic conditions, so what is really happening there, you will be having some MnO4 negative, and in acidic condition it is going to convert into what, that is MnO, uh yeah, sorry, Mn2 positive is there. So in this case there's a formation of Mn2 positive, so this Mn is in +7 and +2 there, so +5 is the change normally, right? So it means simple, it's a very strong oxidizing agent. So let's try to understand this KMnO4, that you can write both the things simultaneously. If you are having a KMnO4 or that is a K2Cr27, and both are in acidic condition, okay, so what is happening? If you are having a primary alcohol, so convert into the carboxylic acid, converted into the carboxylic acid. If you are having a secondary alcohol, so what is happening there, that is it is converted into the ketone. But if you are having a tertiary alcohol, if you are having a tertiary alcohol, so although we discussed that in this case there is a no reaction, right? We discussed already this point, that is no reaction. But listen, that I guess you already know that KMnO4 is one of the strong oxidizing agent. So yes, if you are having a tertiary alcohol, listen my point, that is if you are having a tertiary alcohol is there, tertiary alcohol, no, it's not visible. Okay, if you are having a tertiary alcohol, and then what is going to happen in this case, if you're using a high temperature, okay, high temperature, or we are using KMnO4 as a reagent, so we are getting a mixture, we are getting a mixture of carboxylic acid, okay, it means that particular alcohol is going to break into some part and we are end up with the mixture. So although, like as we know, mixture is never ever important for the organic chemistry, but still we are doing the reaction. Okay, just only the exception is what? If you are having a high temperature or KMnO4, yes, we are getting a mixture. Otherwise, the tertiary alcohol is never ever going to participate in a reaction. Okay, mechanism, how they're going to like form the these things, so it's not important, mechanism part is not important here. Now let's talk about the next one. Okay, so the two part is already covered, okay, so both are same. Now let's talk about this one. It's really important, it's important from the mechanism point of view as well, John's reagent. Okay, so obviously that is John's reagent is discovered by the scientist, that name, the name is what, John, where's the slide? Okay, so now let's talk about the John's reagent. Okay, so let me just write first actually how it's going to work. That first of all, again, you are having a primary alcohol, just write the general reaction, then we are going to discuss further. Okay, if you are having a primary alcohol, again we are end up with the acid, carboxylic acid, and then secondary alcohol, so ketone, and tertiary alcohol, so there is a no reaction, same like the previous one. But how the reaction look like or how to go with the John reason, let's try to understand this. Okay, so let's discuss about this. If let's suppose this is a CH3 and this is a CH2 and this is a OH is there. Okay, we are using John's reagent. So what we are getting simply, that is a CH3 and a double bond and a hydrogen is there. Okay, like this. But the big question, what is this John reagent, right? I'm using again and again John's reagent, John's reagent. But what is this John's reagent, right? So let's try to understand what is this John's reagent. Wait, all I already told you, right? Okay, so let's just discuss about this John's reagent in very much detail now. It's a CrO3 plus H2SO4. Okay, you know what is this H2SO4? It's acid, okay, only. This is the Jones reagent. How it is going to work? Let's try to understand the mechanism first. First, let's try to understand the mechanism. Then we are going to discuss about some general like point, like how to use the Jones reagent because it's really important. So let's start with the mechanism part here, how it is going to react. Okay, so let's talk about the general reaction. First of all, you are having some ROH. Some ROH is there. ROH. Okay then. Then this is the chromium. Let me just write. It's a chromium oxide. Okay, CrO3 simple. And then acid also there. Okay, like as we would already use H2SO4 there. It means for this part, this is nothing H positive ion. So this oxygen has a lone pair attack here. This bond open up like that. Okay, so it means that what we are end up here, chromium, double bond, and ROH and this. Okay, so we are end up with this simply like this. Okay, so this is the thing which is going to react in a reaction, this one. Okay, let me just highlight this. Okay, so let's just cover this complete thing in a bracket. This is the thing which we are going to use now. Okay, let me just explain this step on the next slide now. Otherwise, it's going to be the glittery. Okay, then. So you are having ROH simply now, and you will be having CO and a CO and O and H positive there. So this is the simple thing we are getting now. Same, what you're observing that oxygen has a lone pair and chromium has a obviously double bond there. So obviously it is going to attack. So this oxygen attack on this chromium. Okay, chromium. And this bond open up like this. Okay, cool. So what we are getting that R, O connected with chromium, double bond, and this is a OH group. Okay, like this we are getting, and this one has a hydrogen, and this is a positive charge. Again, try to understand oxygen has a lone pair, attack on a chromium, and since this is a positively charged, okay, so obviously it's going to open up. Maybe this question, ma'am, why not this oxygen open? Because that is already neutral. Why the only the positively charged is going to work? Because it's not neutral there. That's why. Okay, so this is how we are getting now. Same step, like this oxygen simply going to break this bond, and then water is also present into the reaction. So water will like just come with me. Okay, so like this. So what about the next reaction, next step there, that this is O and a double bond, and this is a OH there. So let me just write now this R in a form of C. Okay, so because we're going to use the second point. Okay, so I'm using this R. Okay, wait, let me just change the complete R CH2OH. Okay, because we are going to use the hydrogen. Okay, that's why I'm changing. It's not like that why you're changing, it's a must. Okay, it's not must. So this is simple, R is there. So till now we're getting this. Now how about the second step? Again water came to the picture again. Okay, now water is being like a base. So water simply abstract this hydrogen. Okay, this bond open up like this. Okay, hydrogen break the bond. Again what is happening, that is a hydronium ion release. Okay, and from this hydronium ion also release, and then R C, this bond break, and this is going to leave. So we are ready with this. Okay, aldehyde. Right now we are having only aldehyde. And then look at this part. So simply that is, this is a CO, chromium O negative, and OH is there. So right now we are getting this only. Okay. So yes, this is aldehyde. But maybe this point came in your mind, ma'am. But you just mentioned this, that primary alcohol. Wait, I will observe this. That this is a primary alcohol, and it is going to the convert into the carboxylic acid. So wait, the reaction is not going to stop here. This is the step number one. That is the formation of aldehyde. But as the Jones reagent is a very strong oxidizing agent as well, so the reaction is not going to stop here. This is the only first point here. So I guess I used the Cr. I'm sorry, it's chromium. Okay, chromium. Okay, it's chromium. Okay, my bad. I'm sorry. Chromium have to be there. So now this reaction is not going to stop here. Now let's move further. Okay, after this, the next step is what? So now again, you will be having aldehyde. I know the mechanism is a little bit lengthy, but again we're not going to remember the mechanism, only what is the important there, the how it is going to work. Okay, again that H2SO4 came into the picture. You know the plus factor here, that what is the use of this H2SO4? If H2SO4 is not there, it means if you only use the CrO3, so okay, reaction can be stopped till aldehyde. But if you're using H2SO4, H2SO4 is a base, and base is sorry, H2SO4 is a acid, and acid is responsible for increasing the rate of reaction. So now H2SO4 forcing this aldehyde, you have to react further there. Okay, after this we are going to discuss the next reagent as well. Then you are able to understand my point, what I want to highlight to you. Okay, so first of all, this is H2SO4 again. Oxygen has a lone pair. Let just write the H2SO4 be like this. Okay, this hydrogen simply. So oxygen attack here, this bond open up. Now let me just quickly write that R hydrogen double bond H positive. This bond open up, and then again water is going to attack. And this is going to remove with the help of again the water. But hey, we are not getting carboxylic acid, and you will tell me, is it stable? Is it stable? This given compound is stable. I guess you know some rule already that on a same carbon, if you are having geminal diol, so that is never ever be the stable molecule there. So it means if 2H group connected on a same carbon, so definitely they are going to leave the molecule. Okay, so after this step, what will be the next step? After this, let's just move to the next step here again. So you will be having again R, 2 oxygen, O, hydrogen and OH. Again, our chromium is going to come into the picture. Okay, so this one, like as we discussed, chromium, O double bond, O negative. This part we already covered on the previous slide, if you remember, right? So then OH attack here, this bond open up. So R, C, this part is already there, hydrogen and oxygen, and then chromium, and then double bond O negative and OH positive, like this. I'm sorry. This is going to open up. H positive is also there. Okay, again water. This bond break. Okay, so we are getting a double bond. So we are ready with this, what we want, and this chromium is going to release in a form of that HCrO4 is there. So it's a what? It's a chromic acid. Let me just check. Yeah, HCrO4 is there. Okay, so let's just again brief the mechanism what we just discussed. That is a zone reagent. Chromium is going to combine with H2SO4. This is a step number one. Alcohol combine with this chromium, and then aldehyde generated, but it's not going to sorry, it's going to react further, and it is combined with this, and again, and we're getting diol. It's not stable, and then chromium again going to react, and then so do we have to remember the mechanism? It's not important for the J point of view. What is the only important point here? That the reaction is going to stop toward the carboxylic acid only. Okay, and ketone, same mechanism we are going to follow. So just be noted. You have to remember this part only. But so actually how the reaction is going on, I guess this is clear for you. It's a zone reagent. Now, now. So what we discussed there, that if you're using only if the chromium with H2SO4 there, so we are getting the primary alcohol converted to the carboxylic acid. But in the same reaction, if I am using only the CrO3, if I am using only the CrO3, okay, the this reagent is doing what? That again, if you are having primary alcohol, so we are getting only aldehyde. This is really important. Okay, this is the important point here, that if you are not using any H2SO4, only the CrO3 there, so yes, we are getting aldehyde. Although it's not very frequent reason, because sometime it's not 100% yield. So that's why we're going to use the next reagent, that is a PCC. But before that, let's solve some question from the zone reagent. Okay, let me just give you some question. I know it is a little bit boring, okay, but let's just solve the question, okay? So after that, okay, let's solve some question. One I have to explain, okay? So you are having some OH and it's a chromium oxide and H2SO4. Okay, wait. So can you just tell me between A and B which one is correct? Which one is correct here? Maybe both look similar, but still, which one is correct? Yes. What is the correct answer here? Is it A or is it B? A. Yes, very good, Venom. So why the O is the correct answer? Yes, Lakshmi would also, right? Okay, do you know why is the correct answer here? Because see, the hint is what? The number of carbon. You know, the number of carbon is not going to change. Yes, Niharika also, right? Let's count the number. That is 1, 2, 3, and 4. And in this case, 1, 2, 3, and 4. And in this case, 1, 2, 3, 4, and 5. So be noted. These are the silly mistake mostly done by the student. No, okay, we are going to what this thing, that number of carbon really play a very very much important role here, so hence this is a correct answer here. Now the second question, okay, and for this one you're going to try you're going to answer the question. Same reagent we are going to use and you will tell me the product. Okay, so I will give some option, let me know the answer. Option number one. Option number B. According to you, what is the correct answer here? Oh, sorry. Between A and B, which one is the correct answer here? What is happening, Venom? Between A and B, which one is correct? Hmm. Okay, Lakshmi. But why? Because we discussed, right, that if we are having secondary alcohol, so maybe it is going to convert in the ketone. Okay, B. But why B? Do you know the reason? Simple, because it's aromatic, right? So B noted. Oh, sorry. Where's the slide? B noted. It's already aromatic. So this is the correct answer, not this, because here the aromaticity break. It's not like we are going to convert ocan and we are doing no. Okay. So what is CrO3? It is going to convert the primary alcohol into the carboxylic acid if it is connected with this. Or you can make a note. It is not going to convert the phenolic OH. Okay, it's a phenol part. So phenolic OH is not participate in the reaction. Okay, let's see the third question. Why I'm asking the third question? Because Actually, I want to check a simple point. Okay, last question, please. Same reason we're going to use, okay? It's a option number, okay? It's option number B. Or option C. Or D, none of these. Yeah, you're right, Lakshmi. For the previous question, I guess, right? I guess like my voice and your response, there's a lagging, right? Anyway, answer this question. What is the correct answer? A, B, C, or D? Yes. What is the correct answer? C can also be possible. Why? How means? Okay, of course, definitely it's not that water has become a very good living group and okay, it's going to leave and there's a positive charge generated, right? You don't know. Very honest response, right? So Lakshmi, that C is not going to be the correct. Even C, that maybe you're thinking like that way, that if this is H positive, it's okay, there's a positive charge and okay, there's a hydrogen. But no, we are using oxidizing agent. Obviously, they're not going to displace the position. So what if maybe like just for a while you be like, mom, just put oxygen there, but it's not feasible. Why it is not feasible there? Because one carbon, two carbon, four and five. No, five carbon is not possible. Sorry, five bond is not possible there. So definitely that in this case, this OH will remain same. So this is the only option where the OH will remain same. And some will be like, ma'am, you mentioned that benzene is not going to react. So come on, it's not benzene, it's normally a six-member ring. So yes, it is going to react. So option B is definitely the correct answer for this question. Okay? So this is the important sorted point that I know it's look very scary when this question come, but try to understand John's reagent. What is the function of the John's reagent? Search for the alcohol and which alcohol is going to participate, primary or secondary. If primary, acid. If secondary, ketone. If tertiary, no reaction. And if you to observe, like look at this point here. Let me just highlight. What is it? It's a tertiary alcohol. No, it's not going to react. It's not going to react simply. Okay, I hope this point is clear now. Now let's start with the last two reason, that is a PCC. So what is this PCC? That is, as we already covered, it's a pyridinium. As the name suggests, that is something is connected with the pyridine. Okay, you know what is pyridine? Pyridine is this. And if you're using this word pyridinium, so definitely the nitrogen has a positive charge like this. Okay, CC means C for chlorine and C for chromium. So you can say that is a chloro. Oh, sorry. It's a chlorochromate. Okay, so what is chromate? That this is chromate. Okay, and chlorine connected. So this becomes Cl there. So in this case, what is really happening simply that this is pyridine. Let me just again remove this. It's normal pyridine. Normal, this is a pyridine there. Okay, and wait. And this is OH. This is what? Chlorochromate is there. Now pyridine be like, I'm a base, okay, and you are acid. So sorry, nitrogen simply trap the sides in there, and this is how it's look like. Let me just erase this quickly, and this become that here you are having a H positive ion, or wait, that nitrogen is combined with the hydrogen. It's a N positive, and this becomes normally negative charge. So this is the complete combination become PCC. Okay, So means what is the point? What is the actual really very much important point there? That the conversion. If you are having a primary alcohol, the PCC is the only famous reagent. PCC is the only famous reagent which is famous for what? Conversion of alcohol into the aldehyde. Okay, although we discuss about this that you can use CrO3 alone, dry, okay, dry CrO3 as we discuss, but yield wise the PCC one is really good. Okay, other the second two they will remain same, like if you're having secondary alcohol, so the ketone is the fixed point. But what is the key point? That PCC, if you want aldehyde, just go with the PCC. And tertiary, again it is not going to react. Let's try to understand the consequence of this PCC. Let's solve a question, okay? If I'm using PCC, so what we are getting really that if you're using PCC, first of all check whether it is a primary or secondary or tertiary alcohol. So it's a primary alcohol. Okay, I hope you know how to check it. It's a primary alcohol. So it means this is a simple benzene, and then there's a simple aldehyde formation take place. So yes, if you want to convert a benzyl alcohol into the that benzaldehyde, so yes, you can go with this. This is a PCC. Now answer this question. This is a question for you. Okay, try to answer the question. What we are getting? Yes, please. Oh, let me just write the options, right? Between A and B, just let me know. Between A and B, which one is the correct here? Keton. But both are keton. Hmm? Lakshmi, both are keton. Now, B. Very good. Okay. So it's not like that's a double bond, right? So what is this? There you are having a two hydrogen, and now you are having a four hydrogen. So actually, what is this? What is this? Options are oxidation or reduction. Yes, Niharika. Okay, Venom. Yes, please. What is it? Oxidation or reduction? Reduction, right? Simple. What is it? Addition of hydrogen. And what is it? Reduction. Gain of hydrogen simply. Right? So it's like how it is possible. Just try to understand. Okay, sometimes the option it is very easy to limit the options there. Then how it is possible? Wrong. Directly what is the correct answer? Double bond will remain intact and you will be getting ketones. So very good option B is going to be the correct. Okay. Now let's the last reason that is a copper. Copper, heat, sorry, the temperature is what? That 573 Kelvin. I said Kelvin. Sometime maybe you are not mentioned with the Kelvin. Sometime you are given with 300 degrees Celsius. So be noted everything is same. Okay, so let's do the postmortem of this copper, right? Like what is this going to do? So let's talk about the copper. So in this case, simple, if you're having a primary alcohol, so it is going to convert into what? Aldehyde. So this is the third reason. If you want to convert a primary alcohol into the aldehyde, famous is PCC. You can use this as well, and you can use the chromium oxide dry as well. Okay. Second one, if you're having a secondary alcohol, so it will remain same ketone. And this is like you can say this is a very famous reason for tertiary alcohol. If you are having tertiary alcohol, so we are getting alkenes. Yes, we are getting alkene, double bond. Okay, so let's try to understand that how to go with this. Let's first talk about the first one, aldehyde one. So if let's suppose that is a CH3 and a CH2 and a OH. Okay, we are using this copper heat. Let me just write the temperature. Okay, I'm not using the heat again. So the temperature is what? 573 Kelvin. It's a CH3, CH2. Oh, sorry, aldehyde we're getting, right? Like this. Simple. And okay, it's a primary. And if you're having secondary, same, we are getting ketone. But if you are using tertiary, it's one of the famous reason for this reaction, last reaction, okay? So put 2, 2, 3 to 4 star. It's really much important, okay? So what we are getting, that is, this is a CH3 and a carbon double bond and a CH2 and a CH3. So what is it? 1 and 2 carbon. So how the question frame from this, like, the common name, like this name is mentioned. It's a iso. And how many carbon? That is 4 carbon. So 1, 2, 3, and 4. It's become iso butane. Okay, so it's become isobutane there. That's it. The copper is the only reagent. Every time, not even a single reagent is going to convert into anything. But the only the reagent which convert the tertiary alcohol into the double bond. This is the extra factor here. Okay. First of all, this is all for the theory. Okay. Now let's solve the last question. Okay. After this, we are going to end the class. Okay. Simple. Answer the question, please. Okay, so answer this like which reagent you can use for this reaction. First, this is the question. Second question. First, answer this question, okay? Then I'm giving the option for the next question, please. Just wait, 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 wait. I will. This is the previous slide, okay? Okay, wait. This is the first slide. Which reagent you can prefer? So right now, three reagent, okay? Be noted. PCC, copper we can use, or the one that we covered, chromium, dry chromium oxide. If you're using H2SO4 with the CrO3, so definitely we are going to end up with the acid. Okay, so this is all for the case. Anyway, so let me just write all the reagent. You can use PCC, you can use copper, 573 Kelvin, or you can use chromium oxide, that is a dry chromium oxide. Right? So that's it. This is all for the question. Now, let's talk about this question, okay? Okay, anyway. Okay, for this question, let's solve on the next slide. This question is given, right? We are using copper, 573 Kelvin. You will tell me the answer, okay? So option number one. Wait. Yes, please. What is the correct answer here? Yes, please. Wake up and answer this question. Between A, B, C, and D. Okay, D. Oh, wait. C, this is OH, okay? I'm sorry. OH. Because you are not responding. That's why I thought, like, organic chemistry class is little bit maybe boring. And I also not having any kind of 3D picture, right? Like normal classes. So that's why. Anyway, answer this, please. Only one response, that is, these the correct answer. Your answer is C. So I'm changing the option C, so it is going to be the correct. Okay, then let's try to understand the question. So first of all, the choice number one. Okay, in this case, that okay, like if you have to go to tertiary alcohol, it's a copper. So we know one thing, that is okay, it is going to react. So we are having three choices. Maybe the double bond this side. Okay, if in this case the double bond this side, how many alpha hydrogen? Let's count. One and two, and like here 3 and here 4. Total, with respect to this double bond, you are having a 4 alpha hydrogen if double bond is here. Okay, 4 alpha hydrogen. So let me just write like this, that with respect to this here, it's a 4 alpha hydrogen double bond. Okay, so second one, what is the second possibility? That maybe the double bond form here. If double bond form here, so this OH will be like, I'm not stable. I am not stable. It's a, what is it? That in this case, there is a possibility of what? Keto-enol tautomerism. There is a possibility of keto-enol tautomerism, like this. Okay, so this is the final product we are getting, like after this. Okay, but then the copper be like, okay, wait, I'm erasing this like this. So this is the point we are having. So copper be like, wait, I'm copper. So what is the point of that much kind of drama? I'm only the copper. I can already convert the OH into the ketone. Then what is the point of this ketonal tautomerism? So it's wrong. It is again wrong. Why? Because it's a enol form. It is not going to be the correct answer. Definitely no. So this is not correct. Okay, A is not correct because 4 alpha hydrogen, right? So let me just erase this. Now, the third possibility. Maybe you will be having a double bond here. Okay, look at this. And I'm erasing this. Now let's count for this. How many alpha hydrogen basically in this case? So see this, that move here 1 and 2. And in this case 3, and then 4, 5, 6, 7, 8, 9 total. In this case we're having 9 alpha hydrogen. Oh, this double bond is more substituted. So just by using the double bond concept, we are able to eliminate, that is between option number A, okay, or B and C. This is definitely wrong. Either the option number, like this can be the correct, or this can be the correct. Maybe D is the correct answer, or maybe B is the correct answer. But again, copper is present, and this is a secondary alcohol. This is a secondary alcohol. If it is a secondary, it is definitely going to convert in the ketone. So hence, what is the correct answer for this question? Option number D. Okay, this is how you have to analyze the complete question step by step. Okay, so very good, Lakshmi, and okay, Venom, is this point clear? I'm not smart. Okay, I'm a teacher, so definitely I'm little bit smarter than you, but not very smart. Okay. Yeah, of course, Lakshmi. We have to follow the Setjeff rule, Jetsef rule, okay? Or simple, apply the normal logic, the number of alpha hydrogen. If you don't know the rule name, but at least we know the concept, right? So anyway, this is all from my side. If you're having any problem, please let me know. In today's class, we are able to cover that oxidation part. In the next class, we're going to discuss about the next part, that is miscellaneous reaction. Some weird reaction, some miscellaneous reaction. So that part, the last one. After that, one more session left for ether. So hardly two more session left. Okay, that's it. So yes, done from my side. So Dashika, any doubt? Okay, repeat. I know. Okay, so let me just explain one more time that this is OH. Okay, this is OH. So let's understand, it's a tertiary alcohol. Okay, Dishika. So if this is a tertiary alcohol, I'm using copper and heat there. So what is the point that tertiary alcohol is going to convert in a double bond, right? So first of all, I'm going to select that if OH is connected here, so we are having three possibility for OH. Okay, so let me just erase this OH. The possibility number one may be the double bond form here. Okay, let just take the small point. Okay, let's just wait. Let me just try to make this is a very small. This is the thing we're getting. NOH, NOH. This is the point number one. So in this case, what is the point number one? That may be the double bond form here. Okay, condition number one. And okay, again, what is it? If you have to observe, it's a what? It's a simple. It's a secondary alcohol. So it is going to convert in the ketone. The condition number one. Ketone. Okay, this OH group converted OH and okay. Or with respect to this. Okay, so this is the possibility number one, maybe the double bond form here. Okay, so the condition number two, it is a common point like in both the cases ketone. Okay, so maybe the double bond form here. The condition number three, that it will remain same. Okay, and double bonds, if you are try to form a double bond here, it's feasibly not possible, right? Because if you have to observe this carbon, this red carbon, so how many bond there? Total five carbons, so it's not possible. So just how you are able to observe, like between this and this, maybe that this can be the correct answer, maybe this can be the correct answer. The last one is definitely not the correct answer. So this is how remove this. Now you to select between, let's just use a different color. Okay, like this. Okay, it's okay. So between pink and this sky or blue, whatever you like. Okay, so in this case, how many total hydrogen if you're observing? Let me just highlight the number of hydrogen simply. That this is a double bond. Okay, I hope you already know this is a double bond. It's a group of interest. It's a group of interest. So with respect to this carbon is alpha, this carbon is alpha, or this carbon is alpha. Okay, like this. How many alpha hydrogen? That one hydrogen, two hydrogen, three hydrogen total. So you can say three alpha hydrogen. Okay. Now, how about this? Look at this. With respect to this double bond. So which one is the carbon? One carbon, two carbon, three carbon, and four carbon. Right? So how many total hydrogen if you're observing? That one, two, three, four, and five, six, seven, and eight. Like this. So in this case, total, there's a four alpha, sorry, not four, three. So in this case, that in a final product, you are having three alpha hydrogen, and in this side, you are having total eight alpha hydrogen. So what is the hyperconjugation effect side? That is okay, not an issue, Dishika. Okay, okay. So like uh, if you are having any problems, too, let me know. Okay, so that's why this is the correct answer, eight. Okay, okay, Dishika. Is this point clear? Like how to select the product? That's it. Venom. I'm not going to promote my channel. It's not totally a choice. Okay. If you want to subscribe, you can do. Otherwise, it's not a must. Okay. I just want that at least you to watch the classes. Okay. Because see, I'm not doing for the channel purpose, of course. Okay. I'm doing only for you. So at least join the classes. Because you know, in the very first you're begging, ma'am, please take the classes. And now you are not going to join. Only like hardly seven to eight people is going to join. Okay. So that's why I'm little bit kind of feeling bad. Like, okay, that's it. Okay, good night. Thank you so much. Thanks for joining the class. Okay, now thank you. Of course, because you also joined after so many days, right? I guess in the previous class you're also there. Okay, I don't know about this, Dashika. Okay, there is a new news. I don't know about this because, you know, I don't never was searching the company on Google. So maybe let's see what is going to happen. So thank you so much then. Have a nice day.